Hello, everyone. Thanks for coming, and thanks for taking the road to the hotel. We got some power outage in the main building, so thanks for coming. My name is Eduardo Silva. I'm from ARM, from the team of Treasure Data, and
Masoud Koleini from ARM.
So we are both from ARM, and we are both maintainers of this project, which is called Fluent Bit. And as a deep dive session, this year we decided to start talking about a different approach and different enhancement that we are working together in the data of stream processing and data processing. Logging used to be something that to take logs from one place to the other, but we think that we can take that to the next level, where we can do stream processing and data modification and things that no other tools are doing at the moment. So the whole point of logging is to deal with data. But if you have too much data, it's useless if you're not able to gather the value. And the problem is that data is everywhere. So if you don't extract value, data, as I said, is useless. And if you have a bunch of data, that data is everywhere, and you want to gather these insights, you need to have your data centralized in some place, like a database or a cloud service. So then you can extract the value. And I would say that that is like the main reason behind logging and all this kind of tooling like Fluentd and Fluent Bit. Be able to concentrate your data so you can take advantage of that and extract the proper value. But there are many kind of challenges here. Logging in general is not fun, but also it's not easy because data comes from different places. TCP, UDP, the file system. Nowadays, we have systemd with journald. We have data coming from sensors or remote hardware like firewalls. So how do we be able to collect all this information and centralize all this information that is not just that comes from different places, also different formats? In general, we say that we take this hardware or software data or as events, we centralize them in a database, and then we can do analysis. But we have multiple of them, and you know that every year things are scaling up. If you have a Kubernetes cluster or any kind of environment, it's scaling up in some way. And of course, if it's scaled up, you are getting more data involved, and your data analysis gets some troubles. So as I said, we got these kind of challenges. And if you're familiar with Unix services like Apache, MySQL, you will realize that every data has a different format. Okay? And for a computer, this is just text, right? It's just an array of bytes. There's no difference. So ideally, when we consume this data, in addition to deal with different sources of data, with the formats, we need to have a way to convert this data from an unstructured way to a structured way. We can say that JSON is kind of a structure because we have a map, we have keys, values, arrays, and different data types. But that is not true for all the kind of logs that we have available. And this is where Fluent Bit comes in. Fluent Bit is a project that born as a child project of Fluentd in order to solve different challenges. 4 years ago, forecasting that we're going to need something more lightweight and something that needs to play well either in containers, but also with embedded Linux. It started in 2015. And quickly evolved for the cloud space. And with the cloud space, I mean that people who was running containers or any kind of cloud services said, hey, we are using Fluentd, it's really good, but also we need something lightweight for some special scenarios, like Fluent Bit. Like Edge nodes or something like that. So we started this project with that in mind, and we said, okay, let's develop both projects. And of course, both projects are open source under the CNCF and under the Apache license. Fluent Bit, today talking to people, we realized that it was quite a fun that they were surprised that it's written in C language. Yeah, it's not Go, it's not Rust, it's not Java, it's C language. And people get that question, but when they see the final results in performance, in low CPU and low memory, you say, okay, this project is really good and it's a good fit for different markets. Not just the cloud where you have big servers, but also for embedded Linux. For any kind of data processing or edge computing side, it will work. we have a pluggable architecture. We support different kind of plugins to collect data from, to modify the data, and also ship the data out to any kind of database or cloud service. And of course, we provide built-in security on it. When Fluentd was designed, it was designed in a way that it was considered like a data pipeline. So we say we have an input from where we collect data. We have a parser section or subcomponent where we take some data and we convert from unstructured to structured. Then we have a filter, maybe because you want to filter out information, or maybe you want to append some metadata to your records. We are going to see that right now. Then you buffer your data because you don't want to lose it, and then you are able to route your data to your favorite database. And from a Fluent Bit perspective, we took the same design, the same principles. If you are familiar with Kubernetes or containers, in login, just a simple message that starts as, hey, KubeCon, is not just that message, because also it has a timestamp and also an origin from where this message was generated. So a simple message gets more context. And in Kubernetes, this is not enough, because if you are familiar with Kubernetes, how do you deploy applications? You can say, hey, take this pod, which will be my application, and make 10 replicas. Okay? If you do 10 replicas, likely the replicas will be spawned on different nodes. So at some point, how do you identify when you get some issue on which node the problem is happening, right? On which version of the replicas are getting problems? And this is where we append some context. So for a simple log message, what we get is not only the message, also the stream that is coming from, the pod name, the host name, container name, namespace name, and so on. Because as I said at the beginning, our aim is to perform data analysis. So if you think that you concentrate all your data in one central place, you want to identify where the data is coming from. And this is why a specialized tool as Fluentd and Fluent Bit allows you to add context to every record, to every event that is being generated by applications or hardware. So for us, an application generates something that we call a record. A record is a technical term. And that record, as I said, has a timestamp and a message. But internally, we don't handle that as like an array of bytes at normal text. We use like a binary representation of that message in a format which is called message pack. So message pack considers the binary JSON. So you can serialize data in message pack, and it's quite performant, because if you want to do data analysis and you have a map of 100 of keys, you're not parsing byte per byte. You can skip between each key, and of course, you're going to optimize a memory and CPU. So, and this is how Fluent Bit and Fluentd in general operate. So they take data and convert any kind of information in a binary representation for internal purposes. When the data comes in, this is a quite a global architecture. For example, in the left, we group by all the records by their origin. So we can apply a tag, because we say all this data that is coming from one place will have a tag, and that tag is going to be routed back to any kind of destinations. And so we support like tagging with wildcard matching, and we can send one record to multiple places, which is pretty common. People said, I want to have some kind of records on Elasticsearch, but also I want to push some of them to Amazon for persistency. In Kubernetes, we deploy, how do we solve this logging? It said we deploy Fluentd and Fluent Bit as a daemon set. A daemon set is a pod that runs on every node. And this was a common question, so how it operates. So we deploy Fluent Bit like a sidecar for every application, and that's what it's now. As a daemon set, you consider that in the node, you just deploy one log processor, but this log processor has access to the whole container logs. And once it gets access to the container logs, then it's able to talk to the API server, because as I said before, we want to get all the context for the logs, like labels, annotations, and any kind of information that is not local in the node, but the API server is aware. So if you look at this, you say, okay, you cannot handle this manually, right? You need the right tooling for this. And that's why Fluentd and Fluent Bit has the Kubernetes filter that handle all of these details behind the scenes. So what I'm trying to say, you just need to deploy Fluent Bit and Fluentd as a daemon set, and they will do the work for you. And after that, they are able to push all the logs or information to your desired database or cloud service. It can be Kafka, Influx, AWS, Datadog, or so on. So now a couple of project updates. The project has been running for about 4 years. And they are really happy that we have more than 100 contributors. If you consider this that we are a small company, start a project, and then you see many companies contributing back because of its adoption, because this is working, I think that we feel really happy about this, because also there's one moment that the project is bigger than us, right? It's a community-driven project where different companies are also investing their own time, their own money to make the project better. And the project would not be in the status that is today if it not were for these people. And one of the happy stats for this year is that as of today, we had more than 50 million deployments just on this day, just today. So every day, we're getting like 300,000 deployments in Kubernetes. That means that some cluster is spinning up some VMs or bare metal machine and is deploying Fluent Bit on it. And if you compare that with the last years, so we're doubling, and I think that we will expect like maybe 200 millions for the next year. So this is kind of statistics per month for this year. Of course, November is still growing. This is from the last weekend. But October, we closed with 8 million. 8.5 million, 8.7 million. In terms of who's contributing back to the project, I think that we got a good investment from AWS. AWS said we are going to use Fluent Bit and going to normalize on Fluent Bit for most of our login solutions. And we are going to start implementing their own plugins for Fluent Bit. So AWS is contributing plugins to connect Fluent Bit with their own services, Firelens, Amazon S3, Redshift, and so on. Google Cloud Platform is using Fluent Bit internally too, and Datadog contributed back their own Datadog plugin. So now we are in a position where companies are creating their connectors because they want that the community of Fluent Bit of users be able to use their own services for data aggregation. One of the other news that we have is that I used to be the sole maintainer of this project, but this project is growing. So I would like to say that we have 2 new maintainers. One of them is Masoud, who's here. Masoud has contributed a lot on the stream processor core part, and I think has played a key role on the vision on how this operates. So let's give an applause for Masoud. He has to be very patient with me. And we have a new also contributor who's not here. Sadly, he could not float from Japan. But Fujimoto is managing all the Windows platform port, which, as you know, Windows is a really painful environment for developers. Personally, I want to stay away from it. So hopefully we have somebody with the right expertise. We have Fluent Bit packages for Windows. And we have many people this week working into have a Fluent Bit Windows container for Kubernetes. It's still a work in process. But we got people, hey, this is not working. Well, we need more time for it. Today, we just released Fluent Bit 1.3.3. And just to explain a little bit, we have the major version, which is 1. The stable version 1, major version 3, and the last number becomes some minor fixes. So every time that we release a new version of Fluent Bit, we are aware that if we mess up the things, we are going to mess up thousands of nodes. So you can always rely on the stable version like this, and every time that the last number changes, you can make sure that it's just a bug fix, something that is not working, now it's working, and we test it heavily. Now, a bit of the roadmap where we're going for the next year, at the end of January, I think, we are planning the major release 1.4. One of the features is that config maps. This is not about Kubernetes config maps, But config max is about a way to avoid that you make typos in your configuration or you mess up things and we don't tell you why. So if you have a configuration property called parser and you type of parser A, it will tell you, hey, this is wrong, this is not going to work, these are the right options, and so on. We never imagined that when people use services like this, they make so many mistakes. So many. So we need to provide a way to avoid that. Also, we have a bunch of users who are not using just UTF-8 as a text encoding. They have Latin characters and other kind of encodings where are old, and we are providing support for them too. And we're continuing investing in stream processor. I think Masoud is going to explain that part better. Implement machine learning algorithms, because now Fluent Bit is not just for the cloud. It can run on the edge, and the edge can be anything, a node, an embedded device, or an embedded gateway. And of course, continue improving on performance and connectors. A little introduction about stream processing before to give the word to Masoud. If we consider that when we do stream processing, we say that it's ability to work with data modification or perform data calculation, we have two scenarios. We have the edge and we have the cloud. And this is fine. That is currently working. But most of the stream processor now needs to have a JVM running a couple of clusters in the cloud. And when you want to do data analysis and get faster response from your queries, it takes time, or minutes. It depends on the amount of your data you have. So if you send all your data to the cloud, you have to wait for indexing, or stream processor just complete these jobs to run your own queries. So how can we make it better? So we said, hey, let's build logging on steroids, right? Let's put a stream processor on the logging layer. And why? Well, the why is explained. And how is this? So inside the same logging layer, we are providing stream processing capabilities. So for certain queries or analytics functions that you want to run, you don't need to go to the database. You just run it on the edge, like edge computing, and then you just ship the results out to the cloud. And I'm going to give the word to Masoud, so he will do some demos.
Yeah, thank you, Eduardo. So Eduardo explained that pretty well. And in general, so streams of data, we have streams of data when we collect all the data or logs with Fluent Bit. Like we can have logs, metrics. If you're deploying that on the edge, we can have sensor data that we can read by specific Fluent Bit plugins. And this stream processing on the edge allows us to offload computations from the server side to edge nodes, to the collector, like in Fluent Bit. So assume that you have thousands of nodes, and you're just spreading the computations on these 1,000 nodes instead of waiting for the nodes to send the data to the server, do the computations, and possibly get back to the node. The other thing is that you only send required data to the cloud. So you don't need to send everything. So we'll get back to that later. In general, if you want to write a computation on Fluent Bit and everything, so you prepare not to write complicated code yourself. You need some sort of simple declarative language that you can describe your computation in. So in Fluent Bit stream processing, we are providing a declarative SQL-like language that you can define most of the common computations in that. We have provided loads of functions, and we are also adding more functions to that. And one of the main important things is that it's integrated in Fluent Bit core, written in C. It's pretty fast, and it's very resource efficient. Okay, so many of you may be familiar with Fluent Bit configuration. So we can have a syntax for the streams. Like we can create a stream using the syntax that I will describe later. And I will show that to you later that you can just simply add your stream tasks to a file and just sort of include that file in your Fluent Bit config file. And that's it. It is very simple. So this is a kind of a simple form of how you define a stream task in Fluent Bit. And you can go to documentations and see how exactly can you do that. I will show that to you later in the demo. But you say create a stream with a specific stream name as, and like SQL language, you will have a select statement. You can say select this field, this field, this field from this stream which this stream and the stream name can be your input plugins. Assume that you're reading from memory plugin, and you want to do some sort of averaging over the memory usage. You can say select mem.use from stream memory. And then in general, for stream processors, we have to do the computations over a window of some specific size. So we are defining we have two types of windows here that we collect all the data in the window, and then we do the calculations like average, mean, max, time series functionalities. And these windows we have tumbling window, which, for example, is a window of size 5 seconds, which collects all the data inside, does the computation, sends the computation to the output plugin, throws away everything, waits for the window to be filled. Or we have a hopping window, which many of you may know that as sliding window, which we can have a window of size 5 seconds. We wait for the window to be filled. We move the window 1 second by 1 second and do the calculations over that. And I can say that it is very popular, more than tumbling window. Now we can do the filtering over the records that we get by the where condition, like SQL. So we can just do these calculations and filter all the records by the where condition. And we can also do the group by over the fields that we want. For example, you can have temperature from different temperature sensors in different rooms, and you want to get the average based on the room. So you can use the group by, for example, you say group by room number. Then in the output records, then you will have one record per room for the average temperature. Okay, but where does this stream processor resides in the workflow that we had for Fluent Bit? So the Fluent Bit has input plugins, parser, filter, buffer. And in general, what we do is that, so we sort of pipe the output of the buffer to the stream processor based on the name. For example, if the input is memory, and then we define a SQL that says select these things from stream memory, then we are sort of passing the output of this buffer to our stream processor, and then it is designed in a way that it exactly looks like another input plugin. So you can, again, pass it to filter, buffer, or you can have a sequence of stream processor tasks, one after each other, that makes this very strong, and you can do many different kind of scenarios with that. This is a subset of the functions that we provide. So we have more than that, and we are going to add more than this as well. So we can have average over keys, count, minimum, maximum, and sum. You can have time functions that can be added to your output record, like now, Unix timestamp. One of the important things that we are working on, and we have added currently, is that we have started adding time series functions. For example, we have a forecast function here. You have a stream of memory or CPU. Assume that you have a stream of memory, and you want to forecast when. So what will be the memory usage in the next 100 seconds? And then based on this forecast, you may send some alerts to some services on the cloud. This is actually a simple linear regression here, but it is possible if someone is interested can add more time series functions to that, and we are working on adding more. One important thing, so I don't have that in the demo, but assume that you have a nested JSON. So can we do anything on the nested JSON? So yes, so we are also providing subkeys. So you can do all these kind of operations on key, subkey 1, subkey 2. So if you have a nested JSON, you're still able to use a stream processor. Example, so I will demo this now. So like out of memory forecast. So assume that we have an input plugin memory that we are reading the memory usage on a specific node, and then we want to forecast the memory usage in the next 100 seconds. So this is a simple example of that. You can say select time series forecast. The first parameter is your record time. The second parameter is mem.use, which you read from the input plugin memory, and the third parameter is 100, and if the first parameter is time, it means 100 seconds after the record time. So we want to see what will be the forecast for memory usage on this node in the next 100 seconds. From a stream memory, input memory plugin, And we have a hopping window or sliding window of size 30 seconds that does this forecasting over the 30 seconds. And in general, we read one sample per second. So it's like over the 30 samples and move it 1 second by 1 second. In general, so if you have longer windows, you have a better forecasting, by the way. So you will have less noise in your forecasting. So we'll see that in the demo. OK, so I show you a configuration for that. So we will have Fluent Bit forecast configuration. So if you're familiar with the configuration, you will understand it better. Otherwise, don't worry about that. I wouldn't go through the details. What I wanted to say is that in the section service, you just define a file, the stream file, and the name of the file that you define your stream tasks. And you will have input memory that is tagged as memory. So we'll use that in our query. And I'm sending that to InfluxDB in order to visualize that. And there is another output, so a Slack output, that is just that Eduardo just merged that into master. It's a pretty nice plugin that you can send your alerts here. For example, I'm sending everything that matches the tag alert to Slack. And I'm also showing everything. I'm sending everything to Studio to make sure everything is working fine. And having a quick look at the memory forecast streaming tasks, so it is a bit different from what I showed you. That was a simple thing. You will define your tasks like this. You will define your stream tasks here, and then exec, and you define here as create a stream. I just go through the end now to say that we do from stream memory and a hopping window of 15 seconds, a small hopping window for the sake of the demo. It's better to have a longer one to have less noise and better accuracy. And I'm applying an average over the memory usage, memory used, and I'm trying to also forecast the memory usage in the next 100 seconds and send it to the output record with the name of forecast. Oh, yeah, sure. Is good? OK. So in the second test, for the sake of having less noise, I just read from the above stream forecast and apply an average over the forecast to have a less noisy forecast for the sake of demo, by the way. And now I have another stream here called alert. So I read from this forecast average, the average over the forecast, which is smoother than the forecast, by the way, and create a stream called alert whenever our forecast is over 1.5 gigahertz of memory. That's it. Now we try to run it. OK, so build in Fluent Bit. And the configuration file is demo Fluent Bit forecast. OK, so it's our CD out. So this shows the output of the memory plugin. So this is what memory plugin sends to our forecast stream. After 30 seconds, we are starting to get forecasts as well. So this is the output of the forecast. So I stop here, sort of. So this is a forecast that has average of memory used and the forecast in the next 100 seconds. And this is an average over the forecast. And this is, again, another output from the memory field. So if I go here, I can see, yes, these are the green line is the forecast, and the green line is the average of memory usage. And the yellow one is the forecast, which is almost the same because we are not changing the memory usage on the machine. But now if I start running some service that starts consuming memory, then you can see that the forecasts start to increase. That means that the yellow line shows the forecast in the next 100 seconds. That says that in the next 100 seconds, we have this amount of memory used. Again, because the window is not that long, so you can see some sort of not very smooth changes. But at the end of the day, you can see that it's going up and up. And we are hoping that when it gets to 1.5 gigabytes of memory usage, we will get some alert on a Slack channel that we created for that. OK, we can wait. But while it's showing that, maybe I can move to the other one and just wait for the Slack alert, because we don't have that much time. So, or we can get to that possibly soon. Yep. Close. Mm-hmm. Yes. Puzzle is coming. Oh, here. I didn't get notification, but we are. Oh, I was waiting for the notification, but we are getting alerts on the Slack channel here. So that means that it detects the memory usage and sending alerts for us on the Slack channel. So I was hoping that I get no notification on here on the notification bar, but I didn't. So okay. This is one thing that you can use. Like time series forecast. But one other important thing that we are going to have in the next release is snapshot. Once some team that was working on the edge computation told us, look, so we don't want to send everything like 100 logs per second to the servers. So we want to send data to the servers, to the cloud, only when it is required. So this snapshot is a new feature that is pretty well worked with that. Like we create a snapshot on a stream, and we just flush the snapshot when something happens. For example, on Apache server, so they don't want to send all the info logs to the server, but whenever a 500 error happens, they want to send log to the server. But the point is, when a 500 error happens, you need to see a history of logs in order to debug things. Because of that, we create a snapshot of some size, like here, 5 seconds, from the stream Apache here. And it has a property of 5 seconds or a limit of 10. So we can have the snapshot of size or the number of records or both of them or one of them. Here I added both of them. And here in the second rule, we can say flush a snapshot from this stream Apache when code is 500. Then whenever a 500 error happens, so it flushes the snapshot to the output plugin. This two doesn't need to be the same. So you can create a snapshot on one stream and you can apply a condition on another stream. That makes it pretty flexible. Demo for that. Okay. So for the demo, I just show, I think you have seen that, but I think this is very similar. So in the log snapshot, we exactly have these two things that you saw on the previous slide. So we are reading from an Apache, we are reading Apache logs, and whenever an error 500 happens, we flush that. And I've used some sort of logging, like these are the Apache logs that I'm using as a kind of parse as JSON in a file that I'm just passing those logs to Fluent Bit to see how it works. These are all 200 codes, 200 HTTP status codes. And here I have a 500, and I'm assuming that I'm pumping these logs 1 per second to Fluent Bit, and I'm expecting that I can see at least 5 previous logs on my Slack channel. So if I run this, and what I would do is that I'm reading these Apache logs and sending this to another log file that I'm tailing, simulating reading the logs from Apache. Then it sends the log 1 per second here. And I'm expecting that when I get to 500 error, I get a snapshot of size 5 to our output channel. Yes, you can see that in the std out, and possibly if I go here, you can see that the snapshot is sent to our Slack channel, which you can think of that as the snapshot is sent to your log server, for example. So that means that we are not sending all the logs to the server. We are just sending a snapshot of the log to the server whenever an event happens or error happens, which is very important for edge nodes especially because they have problems with the resource limits. They have problem with bandwidth and everything. So we don't want to send everything. We don't want to consume bandwidth. So that is also a feature that we are going to release in 1.4, I think. And if you have any questions, please ask your questions.
One quick question, if you can hear me. Just now, when you created the snapshot, what was the size you're doing?
So we define the size of the snapshots in two ways. So we can define it in seconds, like the size of the window of the snapshot, or we can have another measurement for that, which is limit. So we can have the snapshots that is of size 10 records or 5 seconds, whichever comes first. Or it's not mandatory to use both of them. So we can use just limit 10. So we keep 10 records, or just size. We keep a snapshot of size 5 seconds.
5 seconds from the moment that the error was found?
Exactly. Yeah.
Yeah, we took like data safety, like for the last 5 seconds, you have different snapshots, one override the other. So when it happens, it takes the last snapshot that belongs to the last 5 seconds with records.
With regards to this ability to provide streams, because it's part of your configuration, I see that there's currently an issue open on Fluent Bit regarding dynamic configuration. Is that something that will be coming along streams so that if, for example, I have this deployed on a bunch of nodes in production, I do a puppet rollout, I want to dynamically tweak my configuration because I made a mistake. Suddenly, I don't get my 500s, I don't get my 200s, I don't get anything. I want to change my config without restarting everything. Is there any kind of support for that? Or plan support?
Well, and that question is forcing us to release our secret to take over the world. But yes, dynamic configuration is something that we have been asked many times. But of course, we got our priorities. And I think that what you see with config maps, which is a way to help users with configuration, it's also a way for plugins to say, hey, this is my configuration, and this is that data types. With that in place, we can implement dynamic configuration, because I don't want to restart a plugin if the new configuration is wrong. And I need a way to validate that beforehand. So config maps is for that also. Second question. This is really cool, really. And I'm very excited, I think, and Masoud too. But also what we are most excited is that you will be able to run SQL queries remotely. So from your own application, you're going to connect to the data pipeline of Fluent Bit. You're going to say, run some SQL queries, and the results will go to your client application. And we are going to add persistency too.
Really cool stuff, really cool demos. Congratulations for that. Now, very simple question. Going back to the roots, one problem that many local forwarders and several software has, which is multi-line logs. How do you support that? How does that be done?
Okay, that's the pushback of today. Multi-line logs. When a Java application or you get a stack trace and your application generate like 20 lines, but the containers handle that like 20 different records. Okay, in Fluent Bit, we support multi-line out of Dockers. You can configure a multi-line mode, and you said the first line of a multi-line stack trace looks like this, so everything after that is a continuation. So we have a way to correlate that. But the problem with containers is that the message is not in the main line, it's inside a record of a JSON. So we are going to add support for that, because people is asking, and yeah, we have to deal with Java.
And many other software which can have many different multi-line types of records, not only one.
Yeah, that's why it's configurable. So you can say how your pattern will look like. So
specify many patterns.
Yeah.
Or it's going to be a gigantic record.
Well, let's start with one. So you can say, this is my first pattern, and maybe you will need to specify another, but that is something that we need to iterate with community.
I can give you a very quick example. Yes, I mean, this is
Yeah.
the problem I'm facing today. So it's the
Sure.
base problem. Phosphorus log records. Many can be multi-line and with many different shapes.
Good use case. Okay.
I can tell you precise examples.
Okay. Cool. Yeah, we have to implement that.
Another question on this, so like when the flush snapshot happens, flush for me basically thinks like you get the records wherever you want it to go, right? It's not a buffer at that point. So can you direct this to like your exec plugin?
Yes. So you define a tag here, and your output plugin will says that if you see the tag, then I will send that to the output server or whatever. So based on this tag, you define, for example, here. So the way that the configuration is written is like, so the output plugin says, whenever a stream comes that matches log underline snapshot underline flush, then send it to Slack. So you match based on this. Yeah.
So you don't want to use a Slack for production, but it's a,
Yeah.
it's a way to do
For alerts, it's pretty good. Many people use Slack for alerts. So you may define your alerts, whatever they have, to tell your maintainers or whatever that something is wrong.
So you spoke of having machine learning capabilities for scanning screens in 1.4 and Java future release. Can you make any more remarks about the kinds of filters you're looking at here, or will it be just plugin architecture? Because we already have like a expression filter.
So it is still under discussion, by the way. So we are trying to see if we can add some sort of TensorFlow capabilities to that. But it is not an easy thing to work on because it might be heavy for edge devices. So that is under discussion. So so at the moment, I'm not sure that if we can release any kind of TensorFlow-based inference or something for version 1.4, but at least we can add more time series functionalities. Yeah.
Sorry, you have a mic, so yeah. Sorry.
Did I understand correctly that multi-line format is coming in the future from the previous gentleman's question?
Yes, it's coming. So we support multi-line, but not multi-line in containers. But it's coming for containers.
If I'm using Fluentd right now with a lot of plugins, can I expect that most of those plugins or similar won't work with Fluent Bit?
No. No. Fluentd is written in Ruby and C, but the API of Fluent Bit is totally different. So yeah. So we build plugins based on community needs. Yeah.
Thank you.
Okay, welcome. Adios. Well, thanks so much for coming, and we are free to talk if you want. Thank you.
Thank you.
Good talk. Thank you.